Hello everyone, I'm Bernard, the founder of Artist-Right Operating System. It's my pleasure to meet you here and have this opportunity to introduce Artist-Right from its very beginning. The first time I have met Linux was in 1998. It was in my college life, and I was a big fan of KDE. When I found the source code of Linux, I was so surprised because we were allowed to compile the source code, the kernel, and even the whole system. That's super cool. So I spent a lot of time to use and learn Linux, such as Red Hat, as well as the many river Linux that has many used KDE at that time. All of this became my best memory. I have been asked many times about how the Artist Right project started. Sure, today I'd like to share that with you. It glows without any intentions. About 2005 and 2006, I wanted to use MCU to make a device with a screen, and there were not any embedded operating system into my list. I started looking for an overall style with Unix locale naming style because of my previous experience with Linux. Unfortunately, Mac OS 2 needs to be excluded, and because it was a MCU hardware, some other open source operating systems that cost too many resources were literally excluded. In the end, write a tiny operating system with a Unix style seems to be my only choice. Why open the code? Basically, it has some relation with my early experience. As I said before, I met Linux during college and was so surprised by its open source culture. Personally, I benefit a lot from open source projects, and I enjoy studying with developers to share the same hobbies. Later on, when I started to work, I got to know VSWorks, a commercial RTOS that impressed me by its professionals, but it was different from Linux open mode, where not so many people could communicate in an open community. So when I decided to create an operating system for embedded devices, I hoped it to be open, not only the code, but also the community. In 2006, the first kernel was released under open source. This kernel used preemptive scheduling algorithm based on thread priority, also include multi-threads, semaphore, mutex, mailbox, and MySQL. It's a very tiny real-time kernel, less than 5,000 lines of code. Resource usage can be as low as 3 kilobytes flash and 1.5 kilobyte RAM. It also includes the extremely high real-time feature with interrupt latency of less than 1 microsecond, and the cycle of task switch in about 200. Because of excellent performance and high stability, it has been used on billions of devices in many fields, such as electricity, industry, railway, consumer electronics, and many others. With more and more functional components added into the system, we started to question what features should a traditional RTOS include. RTOS kernel plus many components make the way obviously large. We started dismantling work around 2017, turning the whole system into one and one modules to make the development work like building blocks. The Artist-Writer kernel, file system, network protocol stack, device driver framework, POSIX API, and many more modules were put into the Artist-Writer operating system platform. With this platform, you can do anything, use the existing components, or create yours. Based on the Artist-Writer platform, we introduced the software packaging. The packages are now all functional modules and embrace all license agreements without forcing developers to use Artist-Writer compatible open source license agreements. Developers make the choice. There now, we have over 300 software packages covered in many areas, such as systems, IoT, security, tool, languages, and more. It happens. We are so lucky to see Artist-Writer growing into a highly customizable and rich feature operating system. Thinking about edge computing and AI, there are more and more requirements to run this function with a lightweight OS, but in a MPU chip, such as ARM Cortex-A or RISC-V 16/4. These chips have MMU. Considering the MCU to MPU, we created the next generation system, Artist-Writer Smart. It's based on the Artist-Writer kernel, but split the whole system into kernel space and user space. Artist-Writer Smart use a macro kernel-like architecture. We only put a few features in the kernel space. The system services such as the file system, network protocol stack, drivers are placed on the user space, making it possible for the kernel to be in very small size, less than 300 kilobytes. So it's fast to start up. The system service has also become a user space process that can be started or upgraded separately and has a separate address space with higher security. More importantly, the Artist-Writer Smart System has the same API environment as Artist-Writer in both the user space and the kernel space, and that supports full POSIX API in the user space. And some Linux applications can run on Artist-Writer Smart without code modifications. It has very high scalability. Looking back, the development history of the Artist-Writer project can be concluded in 4 principles. First, simple design. In Artist-Writer, simplicity is strongly emphasized. And to make things clear, we put kernel file system, share, and many other features were designed into a simple way. The code and the file are the best fit. The second is object-oriented design and implementation, such as thread, semaphore, and the mailbox, and so on of Artist-Writer kernel, which are encapsulated class or object with OOP in C programming language. It makes the code as elegant and tight as possible, as well as guarantee high reusability. Third, obviously modularization. The module and the component programming is another highlight of Artist-Writer. It's clear to understand from the name of the folder and the file. Moreover, each component, such as file system, network protocol stack, device driver, is required to create following the modularization method. Last but not least, easy of use. We are doing a lot of work to make the artisan easy to use and keep you productive. Apart from the system part, we want to thank the power of the development community, which is empowered many energies from this open source project. We have many documents, materials, BSPs, PS from the community, and feedback to the community. You can easily find the support in ArtistRed. Chip support plays an important role in ArtistRed ecosystem. We have supported many chips, ARM chips such as common used STM32, XP IPC, AdMax RT, Phoenix Zinc, or Winner, and many other MCUs. RISC-V chips in Kernel K210, WCH, the CH32V, Proton chip also give support on MIPS such as non-Hing processors. We also put in many effort on the DV board side, include Raspberry Pi with ARM Cortex-A72 and many others. Still now, over 100 DV boards are supported. Welcome to download the ArtistRed distribution and walk through the BSP directory. Most developers are very care about the IDE toolchain. Of course, ArtistRed has done a lot of work to offer you many development ways. The kernel code takes the different compiler supports into account in very early stages. GNU GCC, ALVM, KMDK, AR, and so on are supported. And even some specific toolchains such as tasking have supported the ArtistRed. That aside, whatever community developers want, they can always find support in ArtistRed. In addition to this, we have a side project called ArtistRed Studio, which is all-in-one and free-to-use IDE for developers. ArtistRed Studio includes project creation and management, coding, tailoring, configuration, building, debugging, Flash programming, and so on. We are hoping the Studio tool can minimize the barriers for developers to get started with embedded and IoT development. For sure, if you get used to the command line, you are free to use scans and other professional IDE tools. I want to mention one more point about ArtistRed Studio. It integrated the QEMU simulator that supports STM32 simulation and is available for developing, debugging, and running without having a DV board on the hand. The power of community for an open source project is tremendous. ArtistRed is an open source and community-powered project. Without the support from the community developers, we could never make this happen. We have received up to 5,000 code submissions, 316 software packages, and 6,200 GitHub staff from the community. Also, support the script languages such as Macro, Python, and Lua. Each year, we hold about 14 training sessions and salons, 14 live streams, and 5 online learning sessions. Also, to large-scale develop conference of nearly 1,000 community developers to talk, share, and to discuss the embedded technology and the artificial development. Happy to update. Artificial has 4 Chinese books and 1 English book. All comes from community. You may check out the design and the implementation of artificial operating system book to help you get a better understanding of artificial project. Of course, artificial documentation center also provides lot of get started tutorials. You may have heard about the artificial university plan. We opened artificial courses in over 200 universities, created the joint label in 15 universities, and hold more than 2 online or offline teacher training sessions per year. We welcome universities from all over the world to check the artificial university plan and join us. In March 2020, Artificial started going global. We are looking to let open source project benefit more people. Thank you all for the support.